Welcome to the NetEvents Global IT Summit. I'm happy to kick it off. I have 30 minutes. It's kind of fascinating time in networking. This is right now, I would call again the second coming for networking, because networking is center of the business again. If you look in the 1990s, towards the 2000 timeframe, everybody was going to web. Network was super important. It's once again happening. Network is the business. I want to talk about why, what are the implications of it, how do we go around it, as well as along the way, I'm going to weave in the whole AI, IoT, and security, how it has implications and what we're going to do. Let's start with this. If you look at every one of the industry today, you see that whether it's bookstore, or whether it is video distribution, taxi, every one of the industry, which are traditional industries, which have been there for some of them 50 years, 100 years, are getting disrupted. Every one of them, in a fundamentally different way. We don't go and get taxi, you actually ask the taxi to come to you. You do not go to theaters to watch the movie, you don't go to rent movie, you actually stream it. Things are changing in every industry. When we talk to our customers, every one of the industry, doesn't matter which industry you are in, every one of them are changing. It's around how do you connect users, things, with data and application in ways we have never done before. It's fundamental. It's all around networking. It has grave implications for networking as an industry. We have an opportunity to become the most important part of a business. What are the challenges networking industry faces when we talk about this? We are talking about the priorities are completely changing. If you look at the number of devices that is getting onboarded, if you look at the number of mobility data growth, or if you look at the number of incidents that are happening in security, they're dynamic, they're changing. We're expecting 125 or so devices being connected every second, 25 plus billion new devices coming on board. Most of the companies are actually going to cloud. It's not anymore a question of whether they will or not. These change completely how networking has to work. It's dynamic. The threats are all over the place. The implications are pretty profound. The dollar implications are pretty high. If you look at it at the same time, the way we run the network is quite old. Pretty much most of the changes are manual. If you think about the dynamicity I'm talking about, the number of devices getting onboarded, the security threat, and most of the policy violations are all human error. And nearly 3/4 of the expense is spent towards running the network and keeping up with all the incidents and the tools that are happening. If you really want to move to a digital world, you want to help digitize the business, you cannot do what we are doing. Similarly, if you look at the networking topology, I saw that we're going to talk about SD-WAN. The traditional network is very simple. Branches, talk to data center, you put a firewall, and you go out to the web. Life was very simple. The world had changed dramatically. If you look at it, we don't have users alone, you have things. Branches are popping up all over the places. They could be a mobile branch, could be many different ways of doing things. You now have your data center assets being spread all over the world. It could be in many parts of the cloud. You may be consuming service from the cloud. The topology is changing dramatically. You need to go to a very different way of running the network. We cannot do what we have been doing before. It's time for us to reimagine how we do networking. The traditional way of doing manual operation, the traditional way of doing changes are not going to be sufficient. What do I mean by that? We need to change from being hardware-centric to software-driven. This is what we call a software-defined network. We need to move from manual operation to fully automate. I'm going to talk about certain examples of it. We need to change how we do networking completely. We cannot have bolt-in security. I'm going to talk a lot about the security threat we're going to face that we are seeing day to day today. If you want to solve them, you cannot have a separate firewall. The traditional way of doing it will not work. We need to have security built in as part of the network. You cannot just monitor the network. You really need to understand what is going on. You need to take the insight, and you need to really look at the events in a very different way than what we have done before. So we had to dramatically change from a traditional network to a very new world. In Cisco, we call that as intent-based networking. It's nothing but look at a network, have a controller on top of it, have a way to pull data, have a way to communicate the network in a very concrete way so you can program it. So the controller hides the complexity. This is where you do automation. This is where you do policy. This is where you do analytics. It's actually a closed-loop system. In this, the network we are talking about have built-in security. I will talk about what I mean by that. It's a very different paradigm. They are not bespoke devices. They are here in this type of the network. Wired is not different and wireless is not different. It's a complete, you need to think of them as one single thing. We talk about 5G, I see it. Wi-Fi 6 is predominantly coming along all over the place. When you look at this new network, you cannot treat wired, wireless, and routers to be different. They need to be thought of as a single network with a controller on top of it, and how do you do closed loop? And that's what we are talking. So for the new digital world, you need to move to this new paradigm. What can you do with this new paradigm? First of all, you can address this whole manual effort. I talked about how today the network is brought up. Day 0, day 1, day 2, day n, all the operations. How do you rack stack a box? How do the box gets configured? How do you roll out changes? In this new world, you need to be compliant with security all the time. How do you make changes to the network in a way where you're not bringing the network down? How do you do closed loop? So automation is a key that you can do in this infrastructure. It's fully automated, so you don't need to go manually do the work. In Cisco, we have DNA Center, which is a controller we use, which actually sits on top of our wired, wireless, and routed infrastructure. It has the ability to do these actions. It's just an example of what you need to do to really address the challenge the customers will have, the IT has moving forward. The next thing, this is again one of those interesting things in network. Networking is used to producing a lot of data. We have been doing that forever. Take the early 90s, early 1990s when we started networking, we start producing a lot of data. The problem is that we don't use the data fully. They're all bespoke. Every different routers and switches generated data. We never made sense out of it. In this new world, what we do is we collect data. We have the ability to correlate real time. We create insights, and then we can actually give remediation. When you have thousands of devices coming on every day, there is no way for you to do it manually. When you rely upon wireless, you cannot go one at a time to find out where the problem is. You want the network to be able to tell you what the issue is, suggest remediation. And that's where we are going with this whole intent-based network, which is automated, data-driven. It allows us to understand and be smarter. It understands about application, users, and things, and alerts you whenever there is a problem. It has the ability to give you remediation, that what you need to fix. It frees up IT from being reactive to being proactive. It's a fundamental shift you need to do in networking if you want to be part of the digital journey the business are going through. When you look at security in this new world, it's completely different. The traditional threats are not what we are facing today. The threats are completely different. If you look at it, you see again and again many, many breaches. Data, whether it's credit card or many different industries, it happens all the time. For example, one of the confectionery big company had a malware, and they lost $188 million in one single incident. One incident. A big logistics company, a transportation company, got impacted by malware, lost $300 million, completely came to a grounding halt. It took them months to get back on track. A pharmaceutical company, similar instance. If you look at it in the industry today, the malware attack happens everywhere. Most of the time, it's not fully public. It's happening every day. The interesting thing is, these threats happen at real fast. It took only 4 minutes to bring down a whole network, bring the whole company down. The implications are profound. If you're really trying to move to a digital world, we're trying to digitize, where everything is connected, and a business is running in a very different model, the security threats are also different. The implications are very different. But if you look at it, how this happened is very simple. It doesn't matter. Everybody has their phones or laptops. You're going to a coffee shop, you click the wrong link, you get infected, that laptop comes into a building, in your office, somebody plugs in, that's when the threat starts moving laterally, because the networks today are flat. They move from one to the other part of the network. There are instances where it moved from IoT part of the network to point of sale system network, where they were able to take credit card information. Once you're in, they look for vulnerable spot, then many different threats gets introduced. This is happening every day in many parts of the industry. The reason is very simple. The targets are a lot of money is involved here. There are national state actors are there. They're also trying to find ways to undermine the infrastructure. The threat surface also got changed because we have devices, we have things. We are going to cloud. We let people bring their own device. It fundamentally changes what is happening in the network. So the threat surface had changed dramatically, as well as the threats are also very different. There are many different threats are happening. People are often not trying to steal data. They're trying to encrypt and prevent you from getting access to data, so then you can ask for ransom. It's a very different world we live in this digital world. When you look at that, the scale of the attack, or the complexity, and how sophisticated they are, and how we react, need to be very different. But when we look at it, the network is not prepared for that. Now we see in every instance we have gone through, nearly 100% of them do not have segmentation, keeping things in separate lanes. People, things, guests, separate lane. The flexibility you need, they do not. It takes nearly 200 days to find out, an average, that you have a threat inside your infrastructure. Even worse, it takes 60 days to fix it, because things are done manual. These are very sophisticated attacks. It takes a long time to react. And the implications are profound, millions of dollars per incident. This is the world we live in. When you talk about cybersecurity, cyber threat, this is what every industry is going through today. When you talk about digitizing every business, every one of them are exposed to this. What we need to do is very simple, 3 steps. First of all, you need to segment the network. So you can reduce the attack surface. You can keep them in their own lane, rules and policies which says what is in which lane. Segment it. Second, you need to get full visibility. You need to know about things, people, applications, cloud instances, what is happening. Last but not the least, you need to have an infrastructure that allows you to react fast, real time. As soon as your threat is found, instead of waiting for hours and days, how do you go and shut it down? How do you quarantine it? How do we stop it? And that is where we need to go. Unfortunately, we are very far off in the traditional model. Things are done manual. You got to go enter one at a time. As I talked about it, humans make mistakes too. They don't know the context. They don't know everything that's happening. The traditional segmentation of using VXLAN or VRF or ACL and all those doesn't work. More interestingly, people don't even know what is in their network. They don't know who's connected, what things are connected. They don't even know what is the right segmentation. They don't even know who's allowed to talk to whom. They don't know what policy is ideal for them. The traditional network is not prepared to deal with the situation we are talking. What you really need is something else. You should really like to be able to create the swim lanes. I have employees, I have things, and I have guests or contractors. I have high value assets, and building management systems. They need to be kept separate. Simple rules. You're not talking about IP address here. You're talking about identity. We're talking about understanding what it is and then deciding how I segment. But the reality is this. You know who your employees are, you know some of your high assets, high value assets, but everything else is a swamp. You don't know what is happening there. What you really need to do is you have to start with one. First of all, understand what is in your infrastructure. You have to classify the data. You have to use network to classify what is available, what are the different assets that is connected. Second, you need to understand who is talking to whom. It'll be surprising for you to hear most of the companies do not know. They only know what is leaving their infrastructure, what is coming into the infrastructure, because they have firewalls. When you talk about between laptops, between the infrastructure, within the infrastructure, they have no idea who is talking to whom. If you do not know, you can't construct policy. So you have to learn that. That's the next thing you have to do. Third, you need to author policy. Last but not the least, when you enforce a policy, you need to make sure it is being executed properly. This is the journey we talk about. When we talk about our customers, we talk about software-defined access. This is what we mean by that. It is about how do you move from having thousands and thousands of lines of CLI, where you have no idea using IP address what's happening in the infrastructure, and you hope and pray things are working, to a very different model, where you go to identity-based, where you understand what it is, who it is, and decide policy, and make it secure, simple, and easy to implement. And that is what we talk about. This is what we do in Cisco, called software-defined access. This is SDN done right, in my view, for the access network. This is common for wired, wireless, it doesn't matter. It doesn't matter where you're connected. It doesn't matter globally where you are. You can set policy to say, you know what, employees are not supposed to talk to each other. That means potentially a virus is moving, a malware is moving. You can set this policy, it's very simple, it's auditable. So now we have moved from IP address and things which are not scalable to identity. So when you talk about cybersecurity in digital world, that's what you need to have. This allows you to create a very fundamental part. I talked about how you need to create a fast reacting system. It allows you to create closed loop infrastructure. For example, you have a security infrastructure where you identify a threat, you identify malware. For example, in Cisco's infrastructure, you can talk to DNA center. You can tell, hey, this is a user. I see that user's laptop is infected. We have the ability to talk to your ITSM systems. This is where the policies are there. This could be ServiceNow, because different users and different threats might require different response. These are policy decisions. Sometimes you may say, you know what, this is an exec laptop, so I don't want to completely shut it down. I want to put it in a quarantine zone. Or it's a guest, let me shut it down. It's a thing, I want to stop it. You may have different rules. You may have different rules based upon where this threat is happening. Then the ITSM system, those rules can communicate back to DNA center using API. DNA center being a controller for the infrastructure, it implements the rule. It goes and shuts it down or creates a quarantine zone, whatever you want to do. Then it communicates back to the ITSM system, close the ticket. This happens in minutes. When we talk about threats that we are facing, this is what you need. You need a closed loop security system which understands who you are, where you are, and reacts to the threat in real time. Now let me take to the last leg of my presentation. When you talk about all these things, I'm going to talk a little bit now about the use of AI in networking. I use specific term AI. I'm not talking about ML alone. I will talk about MR as well, machine reasoning. When I talk about having DNA center and having the ability to collect data, analytics, reduce the information, that is awesome. But still, there's too many things that's going on. Your cloud, your application, your business rules you're trying to do, you're having experience for the users, all sort of different things are going on. The ability for IT to do these still is very hard. The alerts per week, the events that are happening, and the number of people they're having, it's not feasible to really still do these with just controller alone. Just doing analytics alone is not sufficient. You need some other tool. If you look at the early 90s, the Industrial Revolution helped humans to get help from machines to do things which is not feasible for humans to do. It's time again. The threats we are facing, the complexity we are facing in networking is not sufficient for humans alone to do it. Brains cannot sufficiently do it. You need help. This is where we have ML and AI comes in. What we do, for example, in Cisco, we collect all the data. I talked about it, what we do analytics. We anonymize it. We send globally to a single place in the globe. Globally, depending on the privacy policy. We take all the knowledge we have got in Cisco, TAC or internal support organizations and engineering, and everywhere we have got, we convert them into models. We combine them. We have the ability to do very interesting things. Let me talk about what we do. I have 3 examples I'm going to talk about. Number one, the left-hand side is very interesting. Generally you look at network, you always have anything you take, you always have some thresholds. If it's above that, give me an alert. If it's below that, give me an alert. It's bandwidth, it's user latency, how much time it took to connect. Anything you take it, you have these things. The interesting thing in networking is that you cannot have a single min or max for anything in your environment, because every environment is different. This conference facility is different from the entrance where people are coming in and signing in, is different from the rooms where people stay. It is different in hotels. Every part of the infrastructure, every environment has different behavior, different day, seasonality. In the morning, people come and go. There is very much difference. Having a single reference point for infrastructure is not sufficient because you have too many alarms. Most of them are not useful. What we do in Cisco, we take the data, we create this green band. This green band is the normal, which is dynamically calculated in the cloud for each facility, each instance, each part of the building. Now it allows us to be a lot more smarter in when we alarm. So instead of alarming every time it is above a static threshold, now it is very dynamic. The dynamicity is per building, per day, morning, evening. We take all into account. It's fascinating when you see the results. We just did a study for 10 customers for 3 months. It's 8,000 anomalies they were getting. When you go through DNA Center, analytics, it converted them to roughly 1,200 issues. When you apply ML, when you do dynamic baselining, it dramatically changes. So when you talk about AI, ML in networking, it is not about changing dramatically things. It's about using these as a tool to actually make us run network in a lot more smarter way, with a lot more efficient way, with a lot fewer people. It's pretty fundamental. Let me talk about the next example. It's very interesting. We are moving to, traffic is getting encrypted everywhere. Encryption is the must. Privacy is important. But then again, when you look at cyber threat, they're all using encryption as a way to hide their malware. So how do you balance identifying a malware, and how do you satisfy the privacy concerns of company? So what we do in Cisco, we actually do machine learning as a way to identify threats that is hidden inside encrypted traffic. We can do it in a way without decrypting the traffic. We can understand what is inside. With very high fidelity, we can understand, say, what the threat is inside is. It works by collecting data, sending into the cloud. We have threat intelligence infrastructure where we analyze. Let me talk about what type of a data we are talking here. We basically, 3 types of data we use to do this one. We take things which are unencrypted. There's enough information there. We send that out per packet. Second, we look at how the data pattern is working, how long the flow is happening, the gap between packets, the size of the packet, the distribution. We collect all those data. These are all fingerprints. These are all signatures for different interactions. We send it to the cloud. We combine that with all the threat intelligence and all the different work we do in the cloud. What this results is pretty fascinating. It allows us to, without decrypting a traffic, we can identify what is inside. We can understand, it's a Google search, it's somebody is trying to update their browser. We can also understand the threat inside. When you look at ML, you absolutely need ML for security in this new world. You need security to understand, you need ML to understand the different patterns. This is just one example of applying ML for security. Without this, it's very difficult to do. We go to the third instance of how we use AI. This is where machine reasoning comes into play. When we talk about machine learning, everybody talks about machine learning all the time. When I talk about AI, there is one of those branches of AI which gets talked less, which is machine reasoning. In Cisco, we use machine reasoning. This is where we come to automation. This is where we talk about how you capture human knowledge and how do you use it to run the network. Because if you look at it, network has all the information we need. We have the visibility. We also have knowledge. It's about how to debug a problem. When there is an issue, how do I find out? Humans know how to do it. There's a workflow. There is a way you debug in IT. We capture all of them. We have a machine reasoning engine that runs inside DNA Center. It allows us to capture all this knowledge as rules, as ontology. And we have these rules created by Cisco. We have in the cloud, DNA Center can download. Now you can apply them in the infrastructure. You can do 2 things. You can do guided remediation, or you can identify issues. It's very powerful. because it's very hard otherwise to replicate the knowledge base that's there in every organization. In Cisco, our goal is to find ways to capture that. So we have tools. So internally we use, there's an editor which allows you to tell what you're trying to do when you debug a problem. You have the ability to convert that into ontology, and you have the ability to download from the cloud so it can be executed at scale by all of our customers. So when I talked about the need for a digital network, you cannot do what we need to do without these kind of tools. And at the end of the day, business is digitizing everywhere. It's fundamentally changing the role of network. It is becoming, one more time, a critical part of the infrastructure. It's part of the business. It is the business. We need a network that need to be agile. We need to be data-driven. It needs to be automation-driven. It also needs to have built-in security. It's time for us to reimagine networking. Thank you.